All right. So we are used to doing the derivative of functions that are y equals something, and that something has an x in it. Y is defined explicitly. We have y equals. But sometimes we have an equation where the y is within the equation itself. So like x minus y squared equals 0. Now, could we solve this for y? Absolutely. What would you have to do if I asked you to solve it for y? Okay. And then we would and then square root. And when you do the square root, you would get a plus and minus with it. So if we went through that process, then I can get it to be y equals, but there's a downside here. Because if I'm going to go and do the derivative of this, I technically now have two equations, right? So we would have to do both of them. Although it is good to practice our skills of solving those equations. So can you guys solve this one for y? When you do the square root, can you do the square root of 100 and the square root of x squared to make it plus or minus 10 minus x?
I did.
Okay, let me ask you a question. If I said x plus 4 squared, can you just take the square root of both and say x squared plus 16? No. So if it's 100 minus x squared to the 1/2, can you take the 1/2 to each of them? No. So you would have to leave it like this. Now, if I were going to do the derivative of that, this one I would have to do my two separate equations, but we also have to do chain rule within there because we have a square root and then we don't just have a plain x inside. So these were not necessarily pretty, but they were solvable. You could get y by itself. Sometimes you can't. If I gave you something like this, x cubed plus y cubed equals 3xy. Okay, I can't actually solve for y on that. I could get my two terms with y on the same side, I could take out a y, but I would never be able to get it to just be y equals. However, we need to be able to do the derivative of those. And it turns out we can. We have to use all of our differentiation rules, so product, quotient, chain rule, all of that, to take the derivative of both sides with respect for x and then solve for dy dx. That's what implicit differentiation means. So, for example, if I'm looking at this one and I wanted the derivative, we could use what we already solved for, but we can do this derivative as it is. The derivative of x squared, we're doing the derivative in terms of x, so when I do the derivative of an x, it's just like normal. So derivative of x squared, okay, plus the derivative of y squared. Okay, y is a variable, so we still do our power rule, 2y, but I want it in terms of x. So every time I do the derivative of a y, I have to put dy dx with it. Right? Think about like all those times we did the derivatives. If I said, y equals 4x cubed, we would say dy dx equals 12x squared, right? The derivative of y was my dy dx. You could also call it y prime, but I strongly discourage that because if you have a y and a y prime side by side, it's easy to get confused there. Equals, what's the derivative of 100? 0. All right, so now you could solve for dy dx. 2y dx is equal to 2x. So dy dx is, if I divide by 2y, x over 1. Oh, that should be a negative though, shouldn't it? I subtracted over my 2x. So we can do these derivatives without first solving for y. Just whenever you do the derivative of a y within it, you put dy dx. This one I did go a step further and I asked for the slope of the tangent line. How do you find the slope of the tangent line? So slope is just the derivative. My x was 6, my y is 8. So we get -3/4. Is that okay? Let's look at a Alright, so if I want the slope of the line tangent to x cubed plus y cubed equals 3xy, and then write the equation of the tangent line. Alright, what do we do first?
The power rule?
Yeah. So the derivative of x cubed would be the derivative of y cubed. Good. Both x and y are variables, so we do both of their derivatives. However, we're doing it in terms of x. So when I do the derivative of a y, it gets dy dx with it. All right, over here, 3xy. Both of these are variables. So I have a 3x times a y. So to do that, we have to do the product rule. So derivative of the first, derivative of 3x is just 3 times the second plus the first, derivative of the second. Derivative of y would be from here, we have to be able to answer the question. So, if I asked for the derivative, we would have to solve for a dy dx. To do that, we need to get the terms with a dy dx on the same side, and then the terms without it on the other side. We have 3y squared dy dx minus 3x dy dx equals 3y minus 3x squared. And so then on the left, we could take out a dy dx. And to get dy dx by itself, you divide. What can we do here?
Cancel.
We can take a 3 out of everything, so it'll be y minus x squared over y squared minus x. That is my actual derivative. The second thing I asked for is the equation of the tangent line. So to get the equation of a tangent line, we need a slope. So we have to plug our x and our y into our derivative. Okay. So we should get -3/4 over 3/4, so we get -1. Plug into y equals mx plus b. Add that over, I get 6/2 over 3, so the y-intercept is 3. So our tangent line is -x plus. Now, if I'm asking for the derivative, you have to go through and find dy dx. If I'm just asking you to write the equation of a tangent line, did I necessarily have to solve for my dy dx first? Could I have plugged my x and my y in and then solve for dy dx? Yeah. So if I need the derivative, you have to go ahead and give me that expression. If I'm just asking for the slope of the tangent line, you are welcome to solve for it or plug in your numbers earlier. So let me show you one where you can do that. So if I want the equation of the tangent line at the origin, so I'm only asking for the equation of the tangent line. That means you do not have to explicitly state the derivative. So if we start here, we have to do the derivative of sine, which is cosine. Inside stays the same. We have to do the chain rule here. So derivative of the inside. What's the derivative of x plus 2y?
1/4. Plus 2.
And what's the derivative of y?
Dy dx.
Okay, on the right, we have a 2x times a cosine y. So we have things being multiplied, so we have product rule. So derivative of the first is 2 times the second plus the first derivative of the second. Derivative of cosine is
100%.
okay, then we need to, inside stays the same, times the derivative of the inside. The inside's just y, but what's the derivative of y? Alright. So we could solve for dy dx, and if I ask for the derivative, you have to. But we could go ahead and just plug in our points. The origin is 0, 0. So if I put 0, 0 in for x and y, I get the cosine of 0 times 1 plus 2 dy dx equals 2 cosine of 0 plus, when I put in a 0 for my x, what happens to this whole term? Yeah, if that whole term drops off, it's just going to be a 0. All right, what is the cosine of 0? Cosine squared of the bottom over 2, so radical 4 over 2 is 1. So I just get 1 times 1 plus 2 dy dx equals 2 times 1 is just 2. So dy dx is 1/2. And that's my slope. So if you plug into y equals mx plus b, or b is 0, bless you. So you just get y equals 1/2 x. Does everyone understand why it was okay for me to plug in x and y earlier on this problem? I want you guys to try a problem. So I want you to find the dy dx on this one, and then give me the equation of the tangent line. So your derivative, you get 2x plus 2y dy dx equals 0. So So if you subtract over your 2x and divide by 2y, you should get negative x over y for part A. And we had to solve for that because I specifically asked for dy dx. Part B, I want the equation of the tangent line at 0.34. So that means the slope is negative 3/4. So then plug into y equals mx plus b. 4 is negative 9/4 plus b. So b is 25/4. So your equation is negative 3/4 x plus 25/4. Is that one okay? I want you to find, on this one I asked for y prime. What is y prime?
Derivative.
Yeah, it's just saying dy dx. So, same thing. You could write y prime in here. I just find my primes end up looking like exponents at some point and it gets very confusing. So, derivative of x cubed,
Derivative.
derivative of y cubed,
3y squared dy.
equals 6xy. So we have two variables being multiplied, so we have to do product rule. So derivative of the first is 6 times the second plus the first derivative of the second. Derivative of y would be dy dx. Right, I need my dy dx's on the same side. So I can subtract over my 3x squared here. Then what would we do?
Dy dx.
So dy dx is 6y minus 3x squared over 3y squared minus 6x. If you can reduce, I would like for you to do so. What could you divide all of those by?
3.
Get 2y minus x squared over y squared minus 2x. What questions do you guys have? Let's try some more then. Do you guys think you could try this one? Give it a shot. So, start off over here, derivative of sine. It's not sine times x plus y, it's sine of x plus y. So derivative of sine is cosine. Inside stays the same. Times derivative of the inside. What's the derivative of x? 1. Plus, what's the derivative of y?
Dy dx.
Equals. Over here, I have y squared times the cosine of x. So we have to do the product rule. So derivative of the first. Derivative of y squared would be
2 plus dy dx.
times the second plus the first derivative of the second. Derivative of cosine is negative sine x. If you were thinking chain rule, derivative of the inside, what's the derivative of x? 1. So there's nothing wrong with trying to do the chain rule there, you'll just be multiplying by 1. All right, this is a mess. Let's start, we have to distribute first. It's going to get worse before it gets better. So we have the cosine of x plus y plus, when I take that times my dy dx is just like your coefficient. Over here we have a 2y dx cosine x minus y squared sine x. So definitely ugly. Ultimately, we have two terms that have a dy dx in it and two terms that don't. So we need the terms with it on one side and the terms without on the other. I am going to move over my y squared sine x just so I can avoid having every term negative, but if you did the other way, that's fine. Can I go ahead and factor out the dy dx as I move this over? Would that be too confusing? So both of these would have it, and we'd have 2y cosine x minus the cosine x plus y. So to get dy dx by itself, you have to divide with the cosine of x plus y. That's y squared sine x over 2y cosine x minus cosine of x plus y. And if you had brought things to the other side, all of your signs would be the opposite, which is totally fine. But you should have the same expression overall. Questions on how are we doing with this overall? I should mention that we're solving for dy dx and all these, but we could very easily switch it. And I think one of the homework questions does, I'm going to throw in an extra one here. If I said y was the independent variable, x is the dependent variable, and find dx dy. Okay. All I did there was flip the x and y. So if I am doing this derivative, let's say my expression was like 4x to the third y equals 2x squared plus y to the fourth. What do you think would change if I asked you to find dx dy instead of dy dx?
Derivative of x would be dx.
Yes. Y is the one that is now the variable that gets nothing with it. When we do the derivative of an x, it gets dx dy. It's saying do the derivative of x in terms of y. So we would have to do the product rule. Derivative of the first would be 12x squared, and I did the derivative of an x, so that gets dx dy times the second plus the first. Derivative of the second, what's the derivative of y now? 1. Over here, 2x squared, the derivative would be 4x dx dy equals 4y cubed. And then we would solve for dx dy. So it doesn't have to be dy dx, it just usually is. So if I were solving, I would subtract over the 4x dx dy and factor out dx dy. Subtract over 4x cubed. Divide and take a 4 out of everything. So I think there is like one problem on homework that asks for dx dy. So same concept, it's just the derivative of x. Get your expression now. All right, let's go ahead and try this one, and then that might be where we stop today. what am I asking you for this time?
Derivative.
Second derivative, okay. To get the second, we have to do the first, so derivative of x to the fourth would be 4x cubed plus y to the fourth would be 4y cubed dy dx. Derivative of 16 is and subtract over my 4x cubed. Divide by 4y cubed, which would reduce to 4, so we just get negative x cubed over y cubed. That's my first derivative. To do the second, the notation, you can use y double prime if you want. In dy dx's, we talked about this at the very beginning, it looks like that, but you could also, if you wanted at this point, switch it to y double prime, you're welcome to. What would I have to do over here? Push. So low d high minus high d low. Again, if you were more comfortable writing y prime in here, that's fine, but I'm going to stick with dy dx over the square. So we have negative 3x squared y cubed plus 3x squared y squared. What is dy dx?
The slope.
It is the slope, but we also know specifically, we already found dy dx was so I'm plugging that in. So when you do the second derivative, you're always going to end up with a dy dx in there somewhere. And that's representing the first derivative, which we know, so you need to simplify that. So if I multiply those, I would get a negative 3x to the fifth over y. I can cancel out 2 of the y's. Well, that should be a 6, right? This was a 3. I think I accidentally changed it to a 2 in the middle. Misread my own handwriting. We don't want to leave a fraction in a fraction, so the easiest way to get rid of it is multiply everything by the denominator, which was y. So my final answer for my second derivative is negative 3x squared y to the fourth minus 3x to the sixth over y to the seventh. These second derivatives do get a little ugly, but our process is the same. Any questions? I feel like I've thrown enough at you for one day, so we're going to stop for today. Technically, you know how to do a lot of these right now. The only ones you definitely can't do, I don't know that you'll get that far. So you can't do the circled ones yet, but the others you could. Tomorrow, we will talk about the last little piece of this that we haven't hit yet, and maybe do a couple more second derivative questions. And then Friday will be a work day, so these are all due on Monday. And I am going to make one change. On problem number 1, it's an ABC question. You only have to do one.